Let's go to Lico 211, design and search word data structure. It let us to design a word dictionary data structure, which we can add word and search this word. The things that for search, there is a dot. It can be a dot which represent any character in the search. So if it is a search, if that is strictly 26 English character, we know this is a classical child problem. But if there is dot, right? So if there is a dot from this dot, we need to um, we need to do search again, right? So we can write a DFS for this kind of search, which is from for a word from a position, and also a try node, um, and also the index, um, which we pass in the try node to do the search. So so when we so the things that for we know this is we if we construct chart from these words, right? In the research we have we need to pass the try node, and um and if we see a dot, um then we pass in the for the channel, which is its child, right? We skip that. In the uh, for the I plus, we have an index. We need to also pass in the index to the index I plus one, right? And also the word. We need to check all of these dots, um, all of the this child scenario, whether it can be searched to is to the end. If there is any one which can return is word, right? So for channel, we of course we need to add a boolean is word flag. If any of this return is word return true, then we return true. Otherwise, we return false. So let's write code for this. So we need a class child node. Let's say we are going to have a child node children, and because we need to search a word, so we need a boolean is word, right? And have a constructor child node, and we're going to have children equals new child node 26, and is false. So in the our main class or the dictionary class, right, we need to have a child node root. So we're going to have root equals new child node. And so for the add word, it is straightforward. So we need a child node, which is a cursor, right, equals root. So for every child, three word to child array. If there is no child, if current data, if current children, c minus a equals none, right? Then we need to create a new child for this. Then we're going to have current dot children c minus a equals new child. And then we are going to move to its child c equals c current. equals current dot children C minus A, right? So after insertion, we need to have current dot is word equals true. And for the search, search because there is a dot in it, right? So what we because if we make those kind of dot sign, we need to do special handling like a DFS or for each because if we have a dot, we need to DFS all of the branches. So we can write a general function return DFS root word and have an index, right? Yeah. So what we do is that the private Boolean DFS we have a child node string word int index. So we are going to have a child node current equals root, and for int I equals index I smaller than word dot length I plus plus, right? So char C equals word dot char at I. So there are two scenarios. One is if C equals a dot, right? In this case, we need um, to DFS all of the index plus the I plus one, right? Trying to see if any of this the the children return true. If any of the children return true, then we return true, right? So else that is this are English character. So we need to write these two scenarios, right? So if this is English character, let's write the easy part. Current. If current dot children C minus A equals none, right? Then we return false. And otherwise we have current if current dot children C minus A, right? And for this kind of word length, right? If we go to the end, we just return current is word. And if there is a dot sign, what we do is that for child node, child current dot children, yeah. So if any of the if any of the DFS, for example, let's say if this child doesn't equal to now, and DFS child word I plus one, right? If any of this return true, we just return true, right? So for any of for that, if there is dot for all of the branches, we didn't find true, return false. Okay, let's take a look. If children C minus A equals none, new child node current Boolean DFS channeled word index smaller than chata if C equals dot for in the DFS word I plus one return true. If none of this, then return false. Else, if current equals not root, should be node, right? Because we write this, we should not pass in the root. For every add or search operation, it will be an OL operation, right? But search, it may be more than OL because there is a dot, right? If there is a lot of dot, so that will be, for example, if all of that will be dot, uh, it will be 26 multiplied by power L, something like that. But if the dot is very small, right, that is also OL. So search, it is something between. But add is a OL operation. We can also write a Python code. So we need a class try node. Yes. So we'll say self dot children equals, let's say this is none multiplied by 26 in self dot is word equals false. So we are in our initial constructor whatever self dot root equals char node. And for the add word, right, we need a current equals self dot root for C in word. So we are going to have index equals ORD-C minus ORD-A, right? So we'll say if current dot children index is none, we're going to have current dot children index equals char node. Then we're going to have current equals current dot children index, right? So after we insert, we just set current is word equals true. So for the search, because we need to do the DFS, right? When we match the dot, so we return self dot DFS self dot root and the word and index 0. Then we define the DFS function, DFS self node. This is a child node. And the word, this is a string. And the index, this is a int, that it is going to return a boolean. The current was node. And for I in range index to length word. So if C equals dot sign, then for child in current dot children, we're going to have if child is not known and self dot DFS child word plus one, right? If any of this one return true, um, return true. And after this for loop, that return false. So if it's dot else, it's not dot, it's a normal character. Um, so if current dot children, if not, if not current dot children, RD C minus RD C, we return false. And otherwise, we have current equals current dot children, RD C minus RD A five. And in the end, we need to return current that is word. This is none, not a node, none. C equals word.